Hi guys, I'm Alex. Let's talk about user-owned AI. User-owned AI is a term that I guess is not very standard, but what we mean by that is how do we deploy, how do we design systems and processes around artificial intelligence such that applications, tools that people use powered by artificial intelligence are not benefiting centralized actors, but benefiting users. And how do we run them in a way that is respectful of the privacy of the user, that it is censorship-resistant, that nobody can decide that a particular set of users don't get to use artificial intelligence. Today I want to talk about two particular aspects of the way we use artificial intelligence today. One is more pressing, more short-term. Another one is more long-term, but more existential, and very much in continuation of what Ben was talking before me here today. The first issue is how do we deploy artificial intelligence in such a way that users can use it without giving away their data? Today, primarily the way we use artificial intelligence is through centralized walled gardens such as ChatGPT, Claude, DeepSeek app, the one hosted by them. And when you use application like that, all your data goes and is stored on those centralized, the centralized providers collect your data. And generally that on itself is not a good idea, though I guess over the past decades, we've been conditioned that this is okay. Most of us use Gmail, giving away already all our data to Google. But if you think about the alternative to that would be some sort of a decentralized system where decentralized nodes run by completely random participants run the model. That is strictly worse, because in this case, you're giving away your data to someone who is completely random, definitely not something you would want to do. Right, so it's very interesting how does one even approach deploying systems that would be competing with centralized companies like OpenAI in a way that users will actually use them, will trust the data. And the second problem that is sort of orthogonal, but the solution to them will be surprisingly similar, is how do we make the community to ensure that going forward, we actually do have competing state-of-the-art systems that are not controlled by centralized entities, right? So until recently, OpenAI and Anthropic were generations ahead of open source alternatives, right? So you as a company, if you build a product that is using artificial intelligence, you either take a dependency on OpenAI, in which case, you're effectively at their mercy. If they decide that you don't get to use it, your company is dead. Or you use open source solution, in which case you're at a disadvantage relative to your competition because your model is less powerful. Now we are at a rare moment when it is not the case. We have DeepSeek, which is competitive with the centralized proprietary models, but that will not be forever, right? So when OpenAI and Anthropic increase the gap again, do we get again to get a model that randomly appears out of nowhere, or do we need to do something to make sure that it does happen, right? And the problem here is very relevant to the name of the event, is that you need to fund the commons. You need somehow people, the community, the society, to make it happen. You need money, you need data, you need compute. All of that is not free. Models are notoriously expensive to train. However, once the model is trained, the way you use it is you either deploy it behind the walled garden, the way ChatGPT is deployed today, in which case it is not in any way community-owned, or you open source it, in which case it is free. Everybody can download it, use it, so you do not get to recoup your, the price of actually training it. Like stability, for example. So Ben used an example of Mistral stability, the same. Two of the companies that were pioneering open source artificial intelligence both had to stop publishing tier 1 artificial intelligence model because the business model just doesn't work. Okay, so now that the problems are presented, I'm gonna start very far, and then I will be building using usual building blocks until we get to a very nice solution. First, I will do a very quick rundown of what are the options to solve those problems, especially the problem of the inference, right? There's multiple problems. Specifically for inference, the most promising one, the most fundamental solution would be what is called FHE, which stands for fully homomorphic encryption, where the model is built in such a way that it is encrypted and your input is encrypted, and the model is being fully executed in the encrypted manner, and nobody can ever see your data, right? Unfortunately for us, the mathematics behind fully homomorphic encryption today is not there, and it's extremely slow, right? It's the overhead is 100x and more to run the model, so it's completely impractical. All right, so I guess the most viable solution today is local. Many people run models locally, but locally you can only run models that are smaller, right? And moreover, it's a very different experience, right? Like if you run something through, like if you use like OpenAI, or if you use Grok, or the ones powered by Fireworks or by Cerebrus, the output is very fast. It's practically real time. Anything that runs locally is much slower, much less enjoyable to use. But the solution I want to talk about is called trusted execution environments. It has practically no overhead, and it's going to be literally no overhead very soon, effectively next year. And it's a concept that easiest to describe with an example of private inference, right? So imagine I'm a user. I want to run inference on someone else's machine. I don't trust OpenAI. I want to use someone, I want to use decentralized service. And there's a hardware provider, which for all I know is probably malicious. And all they want to do is get my data, sell it, or blackmail me. I don't know, right? So if I send them my query, get my response, they have all the data, right? However, Intel processors, AMD processors, most of the processors today have this concept called trusted execution environments. The idea of which is that on the hardware, on the processor, you have a vault with which I, as a user, can establish a connection, and I can run a computation in that vault in such a way that the owner of the hardware has no way of seeing what happens inside, and moreover, I have a proof signed by Intel that is the case. Right, so in this case, I still have to trust someone. I have to trust Intel, but I would way rather trust Intel than that guy. And starting with the most recent GPUs, H100s, and going forward, all the new GPUs, they also have trusted execution environments, meaning that we can deploy machine learning models in a way that they're running on someone else's hardware, but I have full certainty that, unless Intel is colluding with some random person on the internet, I'm safe. Right, and so inference just works, right? I establish, the hardware provider just runs VLLM or any other open source framework that does inference on their machine inside of the TEE. I connect to it. I know I know my connection is secure. I know the code is running inside of the TEE, so it's safe for me to, send my query, get my response. I know that neither my prompt nor responses nor the actual computation can be seen by the owner of the hardware. Now, besides inference, that interestingly enables a lot of very interesting use cases that otherwise many people don't even think about because they, without TEs, fundamentally impossible today. One of them is, if I go to a person and they say, hey, I'm hosting here, DeepSeek v3, you send me my prompt, it's going to be inside of the TE, you get the response, right? Well, and you pay me, the amount of money appropriate for DeepSeek v3. What the malicious hardware owner can do is run a significantly cheaper model, like a 2 billion parameter model, and pretend it's DeepSeek v3. There is no way for me to prove besides observing inferior results, right? But with TEs, what you can do, and there's I have a little bit of technical details here, but I'm not going to go too deep in there. But you can design it in such a way that when I connect to the machine and do the inference, I'm absolutely certain that the model running inside of the TE is the one that the owner promised to me, right? And the core idea happens to be that you compute the hash of the model ahead of time, and it's known. I can recompute it if I want to be 100% certain. And the virtual machine that is running in there is a virtual machine that when it spins up, the first thing it does is it makes sure that the model loaded has the same hash, and if it's not, it crashes, right? And one thing that TE guarantee when I connect to it is that the code running there is in fact the code that the hardware provider promises me it is, right? So I can go to GitHub, look at the virtual machine, see that line that says, hey, I'm going to immediately crash if the model is not DeepSeek R1, but by the fact that I was able to connect to the machine, I know it didn't crash. I know that the model must be, in fact, DeepSeek R1, and then I can use, a model being absolutely certain it's the model that was promised to me. From there, you can take one step forward. And you can say, hey, I have a model, and that model is something I value, right? It could be maybe I trained it from scratch. Maybe I fine-tuned it from I got a existing open source model, but I have proprietary data. I fine-tuned it, and it's a valuable model. What I can do now is I can encrypt the model, put the encrypted model, like on S3, you name it, and then design this virtual machine in such a way that it downloads the model. It has internally a decryption key, but the model can only be decrypted inside of the TE. It can never be decrypted outside, right? And the way it works is that for the first machine, the one I have, I spin up my personal machine, and there is this endpoint set SK, right? I have the secret key, so I set it, and my virtual machine now has it. And then you design the virtual machine in such a way that any two of them can connect to each other, established through Intel that they can trust each other, and then the one that has the secret key will give it to another, right? And so this case, for as long as I know any person in the world who already has the secret key inside of their machine, I can connect to them, get it to mine, and I can get to use the model, but nobody ever will see the secret key besides myself, besides the original creator. Nobody will see the secret key outside of the TE, and they will never be able to decrypt the model, which in itself is not very useful until it can also be verifiable, by the same mechanic I described previously. But what you can do now is you can say that that very virtual machine that now has that can decrypt the model internally would only do inference for you if you establish a payment channel with it and pay for it, right? So now I can distribute the model in a way that is completely decentralized, right? For as long as any person knows anybody else who already has the model, they can get it, right? So nobody, unless the entire world is censoring them, they will be able to get the model. They will be able to get a usable copy locally, but they will not be able to use it without paying me, the model creator, for using it, right? So it's a very important building block, right? Because now you can, if you have a model that is valuable, right, and you put resources into creating it, and people will be willing to pay for it, you don't have to host it behind the walled garden. You can actually distribute it in a decentralized fashion, creating community-owned but not free machine learning models. And that brings me to my final and most cool concept, which is community-owned model, right? So in the previous example, there was still one person in the world who has the model, right? The creator of the model. But that is not, even that sometimes is not desirable, right? So if we want a lot of people, like we want the whole society to chip in to create the, state-of-the-art model, hundreds of people chip in, any person now who has access to the model can run away with it, monetize it, take advantage of it. So what you want to happen is that you want the model to be created in such a way that nobody ever sees it, everyone can use it, and whenever someone uses it, everybody who chipped in to create it gets their royalty. And the way it works, given everything I showed before, is you have a smart contract, right? And the smart contract is orchestrating everything related to the model. And the first thing you do is crowdfunding. That is obviously a completely solved problem in 2025, right? So people fund. Then you have people running hardware. All of them have a specifically designed CVM running, virtual machine running inside of the TEs, right? They provide hardware. The smart contract is orchestrating training. That requires a little more details, but I'm not going to go there, right? Importantly, they can provide hardware, get paid from that money that people crowdfunded. And once it is trained, it exists inside of those CVMs, encrypted, but the encryption key was created inside of the CVM, and no person ever in the world has seen it, right? So the model only exists outside of the TEs in an encrypted form, right? Nobody can ever see, no person or agent or anything will ever see the model unencrypted. It will only exist inside of the CVMs, but anyone can use it, right? Anyone can get the secret key to their CVM, connect to it, open this payment channel, pay for the inference, send the prompt, get the result. And the money, the smart contract will distribute money back to all the people who contributed, right? So that gives you an ability for the society to crowdfund the model, train it, crowdfund the hardware for the model, and then deploy it in a way that is completely decentralized, censorship-resistant, and most importantly, privacy conscious, right? Confidential. So people who use it, they use the CVM by design, by default, meaning that no prompts, no responses, no data is ever seen by anyone besides the user themselves, right? So that's effectively holy grail of decentralized AI. So that's the nice thought experiment I wanted to share with you guys. That concludes my talk. Thanks a lot.